run out of fuel.
What are we going to do now?
Well, we can swim or...
Or what?
Come here.
Ahoy, Mr. Bond. Ahoy, Mr. Bond.
Well, well, what's the matter? Do you need help?
Quite sure you don't.
Well, now that you're here, you'd better give us a tow.
Throw us your line.
Down, down, down. They enchant all the ladies and see all the scenes with their up, and they're down, 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 up and down, flying around, looping the loop and defying the ground. Up and down, they're frightfully keen, those magnificent men in their flying machines.
Well, my old garden chair is taking a hell of a beating here. I think this is the last time I'll be sitting in it. Pretty impressive, eh? Looks like the Spirit of Mackenzie's like a rocket ship going skyward over my shoulder here. And that's because today on the Spirit of Mackenzie YouTube channel, I'm going to be doing the fuel flow test. And according to the Transport Canada's designated inspector, the MDRA, I have to situate the plane at something approximating the maximum possible angle of climb, and I also emptied the fuel tank of fuel to take it down to the absolute unusable level, and then backfilled it a little bit with the minimum load of fuel that's required to do the test. So today, you might have noticed I'm wearing a different hat. And it's got the nice flat top for what I like, because it sits underneath the headset. This is the Westview Flying Club hat. And I was just over in the clubhouse there, and I note on the memorabilia wall that the club was chartered in October of 1953. Now, I feel old sometimes, but the club's older than me, I assure you. Anyway, hats off to the Westview Flying Club. Okay, let's get on with the fuel flow rate test. Wish me luck. I think this is fuel test trial number 3. The first time I did this, the pump had too little fuel to pick up. It wouldn't pump, so I added a bit more, and then I only got 0.65 liters, which I could get a reading off of. That took 1 minute and 9 seconds, and that's the fuel rate I need, 0.56 liters per minute. But now I put a little bit more fuel in on top of the minimum, and let's see if I can get 1.5 liters this time. Okay, so what I'm doing is I have this slightly calibrated juice pitcher here to catch the fuel coming out of the carburetor feed hose on the left side. I'll turn on the fuel pump, hit my timer, run back up here, hold this steady, and when I get 1.5 liters, I'll hit the timer, and I'll have just enough time to run down lower to the cockpit and turn off the fuel pump before this overflows. Let's do it. pumping. Got a nice steady flow there. Okay, up to 1 liter now. One and a half liters. Go, Bob, go, go, go. Okay, well, I didn't spill the fuel, but the Samsung phone took a beating. And my head hit the strut, going under. So the judges' results are in, and I'm pleased to say I think we won the gold medal in that last test number 3. 1.5 liters took 106 seconds to pump from the fuel tank. That's 0.85 liters per minute, and my requirement for the Rotax 912 ULS is only 0.56 liters per minute. One more task checked off. Now that I've established my fuel flow rate is sufficient, and I've got an empty fuel tank, empty of all the fuel except the unusable fuel, and the plane is still propped up at a significant climb angle, I'm ready to calibrate my fuel sensor and fuel gauge here on the EFIS. You might be able to see on this vertical bar that it says CAL question mark, which I assume means calibrate. It's time to calibrate it, so that that I know that when I get a reading here between 0 and 23 US gallons, that's really what's in the tank. But the first thing I'm going to do is I'm going to check the units, because I'm in Canada. We don't use US gallons here, we use liters or imperial gallons. But forget the imperial gallons, I'm going to use liters. So first of all, I'm going to push function keys 7 and 8 and get this into my setup mode, the setup menu, and I can go down to system setup, and I can go down to measurement units. Okay, here's my here's my measurement units. Altitude is going to be in feet, speed is going to be miles per hour, which is kind of a strange one, since normally planes measure their speed in nautical miles per hour, but my old steam style aircraft speed indicator is in miles per hour, and the Searey pilot's operating handbook is in miles per hour, so I'm going to use miles per hour for my speed, as this is already set up for. Interestingly, distance is set up for nautical miles, which is good for navigation. So I'm going to leave that. Temperature is in Fahrenheit. Well, I'm going to change that to Celsius, because we're in Canada. The outside air temperature I'll also change to Celsius. Barometers in inches of mercury, pressures in PSI, manifold is in, I don't have a manifold. Volume, now here's the one I want. Volume, gallons, I'm going to change that to liters. Okay. Well, now here on the vertical fuel gauge indicator, I now have liters. So, one step in the right direction. So, now I'll go to the page where I set up the fuel tank calibration, which according to the Dynon manual is in setup menu again. Okay, and then there's hardware calibration. Oops. we go. Fuel tank 1, main. I only have one fuel tank, which is the main. And it says here, enter the total capacity in liters of the tank and press next. Well, I know the tank is 23 US gallons, but there's a gallon at least, I'm estimating, or according to the pilot's handbook, a gallon of unusable. So I'm going to say my tank should be registering between 0 and 22 US gallons. But I'm going to convert that to liters. So 22 US gallons converts to 83.3 liters. So I'll put that in here. Oops. 3, 4, 5, 83 liters. Okay, so it's telling me the sensor voltage is 5 for a tank capacity entered of 83 liters. And now what it's telling me to do is empty the tank. Yeah, well, it is empty. When it's empty, I press start. Okay. So now I can press start. And it says add 10 liters and press the add button. Right. And I keep doing that until it's full. Then I press full. So basically that's just going to calibrate the tank based on the voltage reading off the sensor, which is in the fuel tank. Okay, good to go. Let's give it a try. 10 liters at a time. Well, that was interesting. As I started to calibrate the fuel tank, interesting, maybe not in a good way. So as I added the fuel and tried to add the data to the dynon, it kept asking me, are you sure the voltage on your fuel sender or sensor did not change? So I accepted the data, added another 10 liters, and got the same message. So obviously the fuel sender, which is this, which goes through the top of the fuel tank, and this is the float which rides on the level of the gasoline. This wasn't working, most likely. It could have been the wire coming from here to the dynon, or the ground wire. So I checked those for continuity and made sure they were right. So it's not the wires, it's got to be the fuel sender. So I took it out of the tank, and sure enough, it's got all sorts of green corrosion products all around it. Interestingly, these two little screws here, which hold this mechanism in place, corroded. They're not stainless steel. This is a standard marine product for measuring the fuel in your boat fuel tank, so pretty cheap. So what I'm going to do first is clean it up, get rid of the corrosion products, and try testing it outside the tank once it's cleaned up. And just by moving the float up and down and trying to calibrate the dynon, I should be able to figure out if this is giving a signal or not. Failing that, I'll buy another one. Should be able to find it online easily enough. Anyway, enough for another day. Made some progress. One step forward, 1¼ steps backwards. There you go. So I've brought this malfunctioning fuel sender back to the Spirit of Mackenzie Global Headquarters Workshop Annex 1B, brackets electrical. And I've tried to clean up this sensor. I had a lot of rust and corrosion products on it, but I wasn't successful really to get it to do what it's supposed to do, which is to measure a change in resistance. As the float comes up, the resistance should change, and that's what the dynon reads to give an indication of the fuel level. So this is a very specific geometrical specification that Progressive Aerodyne requires in the tank in their plane. This is a pretty standard marine fuel sender. But what you can do is you can vary the length of this vertical piece. I cut this off per Progressive Aerodyne specification per the drawing. And I also bent and cut this lever arm per their specification. And I think the purpose was to get it such that where this mounts in the top of the tank, the float then will zero out, come to its lowest point, close to where the fuel outlet is. So when this is down here somewhere, it's measuring zero when it's no longer possible for the tank to provide fuel. And up at the top, near the top of the tank, it measures full. So this specific geometry is required for the Progressive Aerodyne Searey. Interestingly, they supplied the fuel tank, and when it came with this sender in it with instructions to take it out and replace it with this one, which they also supplied. And I think the reason that this doesn't work for them in the Searey is the geometry. You can see that this one on the back has a float that only goes up and down, whereas this one only goes straight up and down, whereas this one goes up and down at a distance removed from the center line. So, interestingly enough, this one doesn't work. It doesn't give a reading, a resistance reading that changes as the float moves. But this one is a really nice sender. It's all stainless steel. It has no wires or moving parts other than the float exposed to the fuel. I'm sorry that it doesn't work because I would like to use it, but obviously this doesn't work in the Searey tank. So what it's useful for is to demonstrate what it's supposed to do. So I've got my multimeter here set up to measure ohms, and if I hook up the leads at this point with the float at the bottom, it's reading 240 ohms, or 242 ohms, which is what it's supposed to read. And then if the float is to rise to the top, say the tank is full, and take the resistance reading again, now we're looking at 31 ohms. And that's the range that these resistance style fuel senders are supposed to show, 30 to 240 ohms. The other requirement is they have this SAE mounting flange, and that they be able to measure tanks that are 6 to 24 inches in depth. These are all the specifications that came with this tank, this sender, which works. 6 to 24 inch gasoline and 33 to 240 ohms. So what I've got to do now, since this one doesn't work, this one works but it's not suitable, I've got to buy a new one of these. Now I've tried to find the vendor online. They're called Boater Sports. They're located somewhere in the States. I phoned the phone number. It's no longer in service. I tried to order online, but apparently they don't ship to Canada, if they even operate anymore. And going through Amazon and eBay, you can find all different types of makes of these. I even located one in the local marine supply store here in town. So I'm gonna buy one that's as close as possible to this, that I can set up in this geometry and it meets all the specs. Problem solved. Wish me luck. Well, it's Sidewalk Superintendent Bob here, checking on the progress of the runway upgrade at the Powell River Airport. They've been at it about 6 weeks now, I believe, and have another 4 weeks to go. They certainly got lots of equipment. They've been working 7 days a week, dawn to dusk. Whether they're making progress, well, obviously they're making some progress, but are they on schedule? This is kind of like me, putting in the hours, but where am I on percent complete? Well, let's hope they're on schedule. Not so much because I gotta get flying, because I don't see the Spirit of Mackenzie being ready in 4 weeks, but
Certainly I want to be able to get on that land plane Pacific Coastal to be able to fly back and forth to Vancouver when I need to. The float plane's enjoyable, but it's not quite as reliable weather-wise as the land plane. And this airport is a little more convenient to my home.
That's all, folks.